Hello, everybody. I will start my today's another live coding session. So in my today's video, I will solve this question: minimum cost to hire K workers. So let me get started. So in this question, there are n workers. I'm given two integer arrays, quality and wage. And quality is the quality of ICE worker, and wage is the minimum wage expectation for ICE worker. We want to hire exactly K workers to form a paid group. Okay. And so, yeah, to hire a group of K workers, we must pay them according to the following rules. Every worker in the paid group must be paid at least their minimum wage expectation. In the group, each worker's pay must be directly proportional to the quality. I see. This means if a worker's quality is double that of another worker in the group, then they must be paid twice as much as the worker. Given the integer k returns the least amount of money needed to form a paid group, satisfying the above conditions. Answer within 10 to the power of minus 5 of the actual answer will be accepted. Okay. So in this question, there are n workers, and I will given two integer arrays, quality and wage. Yep. And I want to hire k workers out of n workers. Yep. And the pace for each of them should satisfy two conditions. And my output should be the least amount of money needed to form a paid group satisfying the above conditions. Okay, so I will return an integer. No, not exactly, not always integer, but float, or maybe I should say number, which represents the total amount of pay for each worker in the paid group. Okay. Yep. And from the condition, I can find that k is smaller than n, so I can always form the paid group out of the n workers. And also, yep, I can find that the quality is more than 1. Okay, so there isn't any negative quality because it messes up the pay. Yep. Okay. So now I could confirm my understanding of this question statement. So let me get started with some examples. Okay, so let me think of this example. So in this example, I will pick 2 workers out of 3 workers to form the paid group. And each worker's quality is 10 and 20 and 5, which means that I have to pay 10 to 20 to 5 ratio. And the minimum wage expectation should be 70 and 50 and 30. Yep. Which means that I need to satisfy the ratio I mentioned, and also each worker's pay must be equal or more than this wage numbers. Okay. So I think this is a brute force approach. And what I can do is pick every combination of K workers, in this case 2 workers, like this. I pick this one, or pick this one and this one, or pick this one and this one. Yeah. And each of these cases, I will think how much I have to pay in total. So let me see. So in the first case, the quality is 1 to 2, so pay has to be 1 to 2. So it should be 70 and 130. Yeah. And the next case, the ratio should be 2 to 1, and the expectation should be 70 and 30. So 70 and 35 is something which means 2 conditions. And in the final case, the expectation is 4-1, and the wage minimum is 50 and 30. This means that 30 and 100, I mean, 120 and 30 meets the condition. I will write it down. Then out of this, the minimum total amount is 105, so I will return 105. Yep, good. Okay, so this is something I can use as a brute force approach. So there are n, I mean, k pairs of combination out of n options. It should be, I mean, nck. And also I have to do the calculation for each pay was out of the k workers. So it should be k times nck is the, yep, time complexity of this brute force approach. So, but I'd like to clarify one thing more, diving deep into in this brute force approach. So there is, once I pick the combination, I decided the pay in, yeah, in this way. I try to clarify the thought process of this because this is, I guess, the most important part in this algorithm, or maybe in this question. So let's say, oh, oh. So I will think of the quality ratio, like, and also I will think of the wage, mini wage. Yeah. In this case, how can I decide the pay for each worker? I think the approach I can take is I always think of the quality per minute expected. So I always think of the expected wage per quality. Yep. So in this case, the wage per quality should be 3.3. This means 10, and this case is 30. Yeah. So that being said, if I pick this worker and this worker, the expected wage per quality should be the larger one, 10. Yeah, because if, okay, let me think. If I follow this first person, whose quality is 3, minimum wage is 10, and give 10 dollars to this worker, in that case, the expected wage per quality is 3.4. And if I that follows that ratio for the second worker, the wage should be 2 times 3.4 is 6.8, which is less than 10. No, which is less than 20. This doesn't meet the expectation of the second worker. So if I'd like to meet both of the workers, what I can do is choose the expected wage per quality, which is the largest in two workers, which is 10. Then I will decide their salary based on that ratio. So in this case, it should be 30 and 20. Yep. So in this way, yep, this means the condition, and which is minimum. I will think of another case. So if I choose first worker and third worker, the wage ratio should be 3.4 or 30. The larger one is 30. So I will choose the ratio 30. So the first worker should get 90 and the third worker should get 30. And for the third worker, the ratio should be, sorry, it should max of 10 and 30, which is 30. So I follow it, and with quality 2, it should be 2 times 30 is 60. And for the third worker, ratio is 30 and quality is 1, so the salary should be 30. Yeah. Okay, so this is it. So in this way, I can decide the ratio and I can decide the salary for each worker. Good. Okay, so now what I can do next is, okay. So basically, I'd like to follow this idea, the expected wage per quality ratio. And with that ratio, I will think how I can, make it optimized. Wait, so mm, what I can see from here is that mm, 10. So I think I have some, possible approaches. I don't know if they work, but the first approach is choose. Oh wait, so what I'm thinking is if I sort by the ratio, actually in this case this is sorted. So when I decided to choose worker with this worker and some worker before that, in this case, ratio is fixed with 3.4 because ratio is sorted and the ratio of the group should be the maximum one in the group. So, for example, if I take a look at 10, the ratio is 10 and I have some workers. I should choose 2 workers in under this person. In that case, I should definitely choose some minimum quality K workers, or just a K minus 1 workers, because yeah, um, the sum of the quality times ratio is the total salary. So definitely, I should choose quality with mini K quality persons. Yeah, so I think that's the approach I can use. So sort by the ratio, and I would think now. Oh, let me make up some case. So let's say sort by ratio, and if core D is 1, so in this case, and let's say ratio is 1, 2, 3, 4, 5, 6, 7, 8. This is quality ratio, and one more thing I have to think is okay. Let's say I have to pick four workers. So if I choose this person, yes, I can choose that person. And I have to pick three more persons, so it doesn't work. Let's say, and then we continue until let me change K to 3. Yeah. At this moment, I have three worker options, 1, 20, and 3. And the, you know, oh, let me change a little bit. So the salary is decided in this way. Yeah, I can choose it in this way. Yeah. And for this person, if I decide that I at least choose this person and people before that person, in that case, ratio is fixed is 4 because that's the largest. Whichever person's workers I choose from the, I mean, workers before him. So if I choose this person, the ratio is decided in this way. Okay. And now I will take a look at this person. If I decide to choose this person, fifth person, always. No, I mean, in that case, the ratio, sorry, if I decide to choose the worker 5 and two more workers from a worker 1 to 4, in that case, ratio is fixed with 5, which is the largest ratio. And which workers should I choose? I should choose, um, the two mini quality workers. Oh, sorry, this isn't correct. It should be like this because I decided to choose that worker. Yeah. So 125, 4, and choose worker 5 and ratio, which is 5. Oh, sorry, this is actually 4. Okay, so what I can observe from here is that as I go through the array, as I go move the index of the last worker, um, the ratio is going up, but the option I can choose as the mini k workers may go down. Yeah. So in that way, the total salary amount can go down or not. Okay, that's the approach I can use. And that being said, what I want is many of k minus 1 workers. So one approach is I can use a sorting to get it, or I can use the mini heap because I always have to keep track of the k minus 1 workers. So I can use the max heap of k minus 1 element size. Then every time I traverse I mean, every step in the traversal, I push the new worker into the max heap, and based on the quality, I pop up the worker with the max quality. So in that way, I can always get the quality of top, no, mini k minus 1 workers. And obviously, I have to keep track of the sum of the mini heap element. Otherwise, I have to, you know, traverse the element in the mini heap, the max heap all the time. Okay, so that's the approach I can take. So I will do two things before implementation. The first thing is I will sort out this idea because it looks a bit complicated. The second thing I will do is the complexity analysis. Yep. So the first thing I will do is calculate ratio. Or I should say build ratio array. Oh, actually, this is optional. As long as I can build this sorted array, that's fine. So what I want is then I will traverse and every step calculate, you know, my okay. So this is it. And for time complexity, assuming that there are n workers, it should be firstly for sorting, n log n time is necessary. And for in line 38, I will traverse the array, there are n step, and for each step, I will push into the heap of size k and pop out of the heap of size k. So it should take n log k for each. This should be n log k. And obviously, k is smaller than n, so it should be n log n. Oh, if this is n log n, I actually don't have to use a heap. I mean, hmm? Oh no, yeah, sorry, I have to use it. Sorry. Okay. Good. And for space complexity, what I will use is a sorted array of size n and mini heap of no max heap of size k. So it should be O of n. Okay, so let me get started with implementation. So as I said, my goal is to build the quality and ratio array. So let me think if I can do it. Yep, obviously I can do it. So quality and So ratio should be wage per quality. Okay. So I get quality ratios. So with this, yep. Okay, let me change it a little bit so it becomes a bit more readable. So I will traverse the array, this array, and as I shown here, oh, I need a mini heap and also global max, global mini. No, global mini total. Okay. Oh, and okay. So what I can do is firstly, um, oh, let me tweak my implementation. I mean, logic a little bit. So I said for each step, I calculate the mini pay total, which is in which I choose the worker as the current pointer and k-1 worker from the previous workers. But I actually don't have to do it. I can say instead of this in line 56 and 57, sorry, this is a bit confusing because yep, I don't use a Python inclusion exclusion range, but I instead more human natural language like expression here. So I will pick k workers in workers until ice index. This works because if the workers at index I should be included, then it's fine. But if it shouldn't be included, the ratio I choose is a bit higher. I mean, it is higher than the actual you know, maximum ratio of picked k workers. But in that case, that is calculated before index I. Yep. So let me quickly show what I mean by that. So if I say I'd like to pick 4 workers, no, 3 workers, and I'm at here, and I use the ratio, sorry, let's say ratio and quality. Both of them should be 1, 3, 5, 7. Case. I choose the ratio here, and I choose a worker 1 and 3 and 5. Yeah. In that case, the ratio is higher than the actual one because I can choose the ratio 5. Yeah. However, this case is already covered in the previous index here because in this index, I choose the ratio 5 and the k workers, I mean 3 workers picked is 1 and 3 and 5. So this is already covered here. So which means that line 61 works. Okay. So what I would do is pick k workers in workers under I. Yeah. So this makes it much easier to think because what I would do is, oh, so this is max heap. Yep. So in line 62, I push current quality into the heap. Then, because I'd like to guess the minimum k workers, I use this as the max heap. And in Python, if I use a heap queue heap push, this works as a mini heap. And to work around that, I mean, to use this as a max heap, I will, multiply -1 to each element. Then I pop out the element. Then, oh, okay. So in this way, I get the h sum. Now h sum is exactly the minimum. Let me rename it. So minimum k quality sum. And so I can say mini total should be this. And I have this global menu. So this is it. Oh, by the way, in line 65, this out is negative. I have to take care of it. So definitely I should do plus equal. A bit confusing. Wait a minute. A bit make it longer, but I think this is much more, less error prone. Okay, so this is it. So let me walk through my code with very simple example, like the first one. So in this case, the first thing I would do is in line 59, I build quality ratio array. Oh, I actually didn't sort it. Okay. Wait, it totally doesn't work. Wait a minute. So quality ratio array. Actually, I'd like to, you know, sort by ratio. So the sort, I mean, ratio has to come first. Okay. And here, this will be this, and ratio comes first. Okay, so this is it. Good. So let me go back to the working through. So in line 61, I, you know, build the array, which looks like this. The wage is 70 and quality is 10. So ratio is 7 and quality is 10. Okay. Then for the second element, the ratio should be 2.5 and quality should be 20. Okay. Then for the third one, the ratio should be 6 and the quality should be 5. Okay. And this is now sorted. So like this. Okay. So now I will initiate some heap and heap sum. So currently it's empty and heap sum also. And the global mean total should be infinity first. Okay. I go to line 73 and let me delete it. For index 0, what I will do is in line 75, current ratio, current quality is ratio quality array, index 0. So it should be 2.5 and 20. So firstly, I push this into the mini heap. So now minus 20 is in the mini heap. No, sorry, heap. Actually, max heap. And heap sum should be no 20. Okay. Then in line 78, because k is 2, length of the heap is still less than k. So I go to line 83. Oh, I forgot something. So now I'm calculating the mini total, but this is the case only when there are k elements, exactly k element in the mini heap. Otherwise, I can calculate the, mini total, but actually I didn't pick k workers. So I make the change. Okay. Yep. So now I don't do anything here and go back to, line 73 with I1. So when I is 1, it should be 6 and 5. The current ratio is 5 and current quality is 5. So I push minus current quality, which is minus 6. Good. And now in line 78, length of the heap is 2, which is not larger than k, which is 2. So I go to line 83 and length of the heap is 2, which is smaller than K3. So I go to line 84, and this is the case. So I go back to line 73. And now I is 2. Yep. So current ratio, current quality is 710. So I go to line 76 and push -10 into the mini heap. Good. And now H sum plus equal current quality. So this becomes 30. Oh, wait. I forgot to do this in the last step. It should become 26 before, and currently it should be 36. Okay. So now length of the heap is 3, which is not larger than, no, sorry, which is larger than 2. So in line 79, I pop out one element from heap because the mini one is popped out. -20 is popped out. So negative out is a -20. So out is 20, and heap sum is 36 minus 20 is 16. This is actually correct because there are two elements, 6 and 10 in the mini heap. No, heap. Okay. And in line 83, K, which is 2, yep, is equal to rank stage. Yes. And I go to line 84 and I go into the if statement. So in line 85, mini K quality sum is H sum, which is 16. Okay. Oh. And mini total is mini K quality sum, which is 16 times current ratio, which is 7. Yep. So wait. I think I made mistake somewhere. So this should be -5. Sorry. Not 6, but not actually I should have pushed 5. Okay. That being said, so now mini K quality sum is 15 and current ratio is now 7. So global mean total should, no, sorry, mini total is 105. So global mean total is updated with 105. And that should be returned in the end. Good. So I'm pretty confident in my code. Even though one thing I couldn't confirm is, oh wait, no, I could cover everything, every line of my implementation. Great. So I'm pretty confident in my code, so I will submit. Good. Great. Okay. So let me quickly wrap up today's coding practice. So today I solved the question minimum cost to hire K workers. And in this question, I was given the list, I mean, there are N workers in total. And I'm given the integer array quality and integer array wage, which is the minimum expectation salary from each worker. And my task is to, hire exactly K workers from those N workers. And I have to, you know, hire such K workers to meet two conditions. Yep. Okay. Condition number one is to make the total wage minimum. Number two is for the workers hired, their salary is proportional to the quality, yeah, of that worker. So that being said, in my solution, I use the sorting and max heap, yep, combination of them. So I sorted the workers I sorted the workers by the expectation ratio, which is exactly the wage per quality. Then I traverse such that ratio array, and because sorry, I sorted the ratio array. Then I traverse the ratio array. Because ratio array is sorted in ascending order, or I should say non-decreasing order. If I decided to choose workers under that current index, the ratio is fixed with that. And with that, I had to choose K workers with mini qualities, or I should say mini K quality workers. Yeah. So I use max heap to do that iteratively. Yep. In this way, I can solve this question in n log n time. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.